Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. You know, in one or more of our previous episodes, we've talked about how you basically learned reliability with a handful of mentors. You know, and Dr. Hobbs and a handful of others kind of taught you the ropes, taught you the process, the philosophies, the way you approach problems in the field. And I have a handful of folks that I've, point to as mentors that I learn statistics, and I learn the fundamental need to do root cause analysis and, speak with data, things like that. But you and I have been to conferences, we've given papers, we've listened to, I don't know how many papers, we reviewed papers. You wrote a book. There's so many courses and lessons and workshops and everything else. I dare say you probably even read a book or two. Right. But of all of those things, all of these different ways that we learn our trade are the skills and the tools and the techniques and the processes and stuff like that. What would you say is the best way? If you had a magic wand and you walk an organization, we're going to teach you about reliability. What's the best way to do that?
Well, I'd first go into a company and say, have you made a product before? And they say, yes. I said, did you have any failures of that product in production or in the field?
Why do you say
that? Yes, we have.
Why do you say that? They failed. We didn't expect them to fail, so that shouldn't have happened. But how did you know?
Okay. Do you have some of those failed products in-house, or have you kept them? Or did you do a root cause analysis on what caused the failure? And can I see that data, please? Oh, well,
we shipped it to the vendor. We don't like failures, so we threw it away.
Yeah.
They're such a downer.
The best way to learn about reliability is look into the unreliable instances of the failures in the field, whether it could have been training or, usage or misuse by the customer. There's many reasons. It could be a good design, but the customer
the wrong product for that environment.
Exactly,
it could be a perfect design, but it's in the wrong hands or wrong design. So, I mean, is the best reliability training train our operators on how to use it well? And would that make it better? In some cases, it would.
This was a dilemma that Boeing had to deal with, and I mentioned a post. If you go to my LinkedIn site or my page for LinkedIn, you'll see I made a post about the Netflix documentary on Boeing, the downfall, basically the problem with the 737 MAX 8 airplane. And the control systems that they had to change because they extended the number of passengers by extending the fuselage. Well, they put I think they put a bigger engine or a more fuel efficient engine. And because of that engine's design, they had to put in a modified system called the MCAS, MCAS, that actually controlled the aileron or the back, I guess, what do you call it? The back.
I always called it a flipper, but that's probably not right.
Anyway, it would compensate. Okay, because of these powerful engines, the tendency was for the airplane's nose to go up, and so they put in an automatic control system that, unfortunately, and this was a big, amazing overlooked weak link in this whole system, was that they had one sensor, the angle of attack sensor. They were relying on one sensor with no verification, no backup, no other control verification that this sensor was correct or wrong or not working. And in the United States, thousands of flights went on. Apparently, I think the Boeing's big argument or big challenge there was that they didn't want to have to retrain the pilots because of the incredible expense for all the airlines if they put that out, and the cost would be, and the demand for their ability to fly that plane would be dependent on all the training that they would have to do with all the thousands of pilots across the world, and it may apply in that. And so they really avoided totally from recognizing that absolutely training was necessary to make the pilots aware, which in the two planes that crashed, the pilots were not aware that there was this auxiliary system controlling the plane, and they were fighting a computer control based on a faulty information from one sensor, forcing the plane to put its nose down, even though it was flying correctly. And so the pilots, by the time they had learned that, at least one set of pilots on one of the planes had turned off the system, but because of the high velocity of the plane, it was too late. And later in the failure analysis, they realized that if the pilot did not act and turn off the system within 10 seconds of its miscontrol, it would be too late. It would send the plane in such an angle downward angle that you could not recover from. Yeah.
And part of the argument there is, some products, you do have to do training for the people going to use it. I mean, I wouldn't get on a backhoe without somebody saying, "Oh, this is how you go use this thing." Like when I rent equipment at a equipment rental, they spend the time to go, all right, here's how you turn it on and off. Here's the safety features. Here's things to be aware of, and it's pretty minimal, but the machines are pretty robust, like a rotor tiller or something like that. And they're dangerous. But so they give you the basics pretty darn quick. Now, something more complex and you got 4,000 switches in front of you, it might be a little more complicated. But the reliability training, for the pilots and for this kind of situation is just obviously a safety issue, but it's a reliability. Some element of that system failed for some reason, for whatever reason. Now, back into the day, some products like a phone, a modern day touchscreen phone, is that it doesn't come with an instruction manual.
No, you shouldn't have to be trained, right?
And
it's intuitive.
And if it doesn't work, you're frustrated and you don't use it, right? It's not going to crash the plane.
With 300 people aboard. Right. Okay.
But the notion is that there's a balance of, there's a part of the best reliability training, and where you were going initially is your previous products, the field failures you've had, the things that are in customers' hands being used by customers and where they want to use it and what works and what doesn't work, and then learn from that. So are you saying that we should teach our customers to do root cause analysis for us, and then we don't have to do it? But you've run into organizations that their root cause analysis isolate the component that you think is faulty and ship it back to the vendor. And that's the entire process. And I'm like, that's probably not working for you guys. How'd you know that? Well, let's think about it. But, learning from failures is a reactive process. How do you get ahead of that? How do you avoid failures? Because you don't want to wait until you made all the mistakes. Now, you and I are old enough that we've made a good number of them, more than we want to admit, and have run across so many different issues that we've got a portfolio of stories of things that failed. But how do we help the next generation avoid those?
Fred, I
listen to the podcast.
Yeah, exactly. How do we do it? We do better testing. We do better focus on or maybe our FMEAs and
risk assessment stuff, yeah.
risk assessments, and do focus our attention to those critical systems, and then at a system level, making sure that not only does this one section work, but it interfaces well even under variation with the next system, that you may buy from a vendor. Power supply, whatever. Does it have the right regulation? That that's going to be enough regulation on that power supply to handle the variable load that this board is going to ask for, and things like that. I mean, it's just, again, I think you can get, this is, again, when David Packard said this is the one way, essentially, I'm paraphrasing his quote, there's only one way to improve reliability. Models may help to some extent, but the only way is to build, test, and fix those things that fail, and repeat the process until the goal of acceptable reliability or robustness is achieved. And that's the only way. There's only one way to do that. But I'd say that we're missing a lot when we don't monitor our tests. We're not monitoring the right things. We're not doing enough samples or pushing it far enough. I mean, I think all those things have to happen, and we all do those. But on the testing part, most companies could do a lot more and be willing to go to the limits. And we don't want to say, I don't like using failure because it's so
a connotation.
Negative. It just slams the door shut in a lot of people's brain to testing better.
But you and I have a world of experience in all kinds of labs and products and testing and root cause analysis and design work and all kinds of stuff. Right. And have actually gotten to talk to customers and, on occasion, which every engineer needs to do. But what about and that I teach at
marketing is very careful about engineers talking to customers.
Yeah, too many Dilbert cartoons out there to scare them away.
Yeah, right.
But I teach a course on reliability engineering management at University of Maryland, and vast majority of the courses in the master's and PhD program are your favorite topic, the Weibull analysis, or should you use the gamma analysis instead, or modeling, or physics of failure type stuff. And we got to use the gamma function today because it's National Gamma Function Day, and
a totally different world than manufacturing and real reliability. Yes, go ahead.
But if that's where And my experience is limited just to a handful of university programs. And I'm sure there are some that are very practical and some are very good. But the theoretical stuff is, if you're going to get a PhD in reliability engineering, it usually means you got to do some pretty serious math and you got to do some serious modeling. And you got to understand all of these concepts that are theoretical. But why are they teaching them that stuff when they, here's a product, go fix it? Is what we're saying is a way to learn.
Well, Fred, I still I see a lot of reliability engineering and reliability fairly still having a strong influence from the military industrial complex, and since that is a huge budget item and it's been increased again, that there's still the very big profit motive of contracting and making a minimally reliable product, and that's where a lot of the people that go to industry. Mm-hmm. Also, I don't think academics, and I give credit to Michael Peck, Professor Michael Peck, who I've known for over 25 years now, and we've wrote a paper together and some other things, but from an academic standpoint, they're only exposed to the things that companies want to expose them. CALS has a consortium, and they are basically at the request of their consortium members on what they're going to study
and what they're going to fund.
what they're going to fund, right?
What they're going to fund. Yeah, I was part of that team once. I was representing a company, and we're interested in heat sinks and dust buildup on them. So they went off and explored that. They have a bevy of grad students that did a great job of it. But,
and they're doing great work on lithium-ion batteries because that's certainly becoming much a hot topic with the Boeing 777 having fired. yeah. And a few things, a few batteries blowing up, like the Dell laptops, actually it was a different vendor that provided those batteries, and they did have other problems. But because of that, those kinds of things happen.
Well, it helps. I mean, there's something to be said to, look at things that you're interested in or curious about or have a question about. And CALS has resources that can make those kinds of studies happen.
Right. Exactly. Right. They're regular and fixed and like wear of a tire tread, or things like that.
Right. But they also have a FA lab. I think they still do. And so they get kind of a pulse of what's going on in the industry. And this is an electronics industry mostly. Right. And so they get a sense of what's causing problems, and they can propose studies to help fix that. But I think underlying both what you talked about with what Packard said and what like Hobbs, I'm sure, has said, and what you're talking about now with CALS is you got to be curious. The best training we got is simply notice that doesn't look right, or that smells funny, or I don't know enough about that. And you don't need a PhD to ask those questions.
No.
And so there's some argument that getting a PhD and going through that rigor gives you the ability to ask better questions. And there's all kinds of argument on that. But the idea is that the best reliability training, in my mind, is your own curiosity. And then you got to be tenacious about it to follow through and make the case and do the investigations and read the books and listen to the podcasts and everything else. But every day you should learn something you didn't know before, and when it's in reliability, you're going to be way behind if it's only one thing per day.
But you also need to have a situational awareness about reliability failures.
Yep.
So many of those are caused by an error, and somebody may be responsible for that error. Okay, and so many cases they don't want to talk about it. Yep. They don't want to expose it. They don't want to. Certainly, the public and or the competitors, they certainly don't want those things to be known to them, to the public or whatever. So
that's a cultural.
Not easy.
It's
they
not
don't
easy.
Just hand you books on the failure analysis they've done.
Oh, I don't know. I've done this for years and years and years. You're visiting a client and we go to lunch and there's like 3-4 of us sitting down to lunch someplace, usually at a cafeteria in their building. Right.
Yeah.
And I'm under NDA and all the other happy stuff. And so a common topic I bring up is, so you guys have any, major disasters? What's the last 2 or 3 that you've, big issues you've had? And usually it leads to some fascinating stories. Like you're talking about this Varactor, and it's fascinating how that sorts itself out and you figure things out like that. And so I learned about it. It's just, be curious about it. Now you have to have the trust and the legal shields, and I think that's part of it. But it's still asking that question and then getting those stories. And the funny thing I've learned over the years is that people remember the 3 big ones, but not everybody remembers the same ones. Depends on what you were involved with and what part of the organization were. So this one organization, there's 3 guys sitting there and they came up with 9 completely different stories. And they were all arguing with each other which one was the best one or the worst one. It's funny. But they learned from each other. It's, I didn't know that could do that. Because one was a mechanical engineer, one's an electrical engineer. And they were like, that can happen with that. And so they could learn from each other if they would just talk about it. that kind of thing. So it was, once I ran into that, I always asked that question. But so we're saying the best way to learn reliability, one, is just do it, right? Be curious, ask questions, and be aware of what's going on.
Investigate, understand unreliability, okay, from whatever product, because it's usually, and it's fairly common, and it's unique. I mean, it's unique to each company and each manufacturing line and each product. There's just there's so many different reasons, and that's why, again, it's you can't really model most of the unreliability. You can't model because it's not intrinsic wear out modes that is the cause. It's a mistake in the design, or
you can model that too. You can model the rate of mistakes in designs. There's all kinds of ways to go about it, but is it worth doing?
Everything else is the same on a manufacturing line? Yeah, probably.
No, there's all kinds of ways to go about doing stuff. The basic idea, though, is that papers, books, conferences, workshops, webinars, podcasts, like this one, for example, and all of these other outlets for our professional engineering knowledge type stuff, the stuff we all share with each other, allows us to learn the language, to increase our awareness of what's working or what's not working. It increases our sensitivity to things. It may improve your ability to do root cause analysis and understand issues, even if it's nothing more than networking. And you learn, well, there's other people that know a lot more about this. Let me get in touch with them and ask a question or two.
Exactly.
There's so many ways you can learn. So the best reliability training or education you can have is be curious.
That's right. The 5 whys came from that. And actually, there's many more than 5s usually.
Usually, yeah. So Accendo Reliability's got a lot of the core stuff, papers and podcasts and webinars and all other good stuff. Kirk, you've got a book out there. It's up on the site. You can get it through there. You get it at Amazon. There's lots of information out there. And those are all supporting parts of your education. And my education, frankly, but there's lots of ways to go about doing this. So if you're listening to this and you made it this far, and you know what I'm going to say is, let us know what you think. What's your take on this? What's the best training in support, whether for yourself, for your organization, or for your customers? What's the right way to approach this, and what's the best way? And
exactly,
you can let us know over at accendoreliability.com/go/SOR. There's a SpeakPipe widget there. You can leave us a message, or you can leave us a written message. Kirk and I and the other hosts are available on LinkedIn and on Accendo on our About pages. Lots of ways for you to join the conversation.
Yes, please send us your questions. We love hearing from our listeners.
We certainly do. All right. Well, thanks so much, Kirk. I think I'm going to sign up for a class this afternoon. I'm not sure about that.
Okay, Fred, go for it. There's always more education.
That's right. All right. We'll talk to you later, Kirk.
All right, Fred.
Cheers.
Take care.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.